All right, good morning or afternoon or whatever time this is when you are watching this. I am making this video for my calc students. The, the idea here is I'm going to go over certain topics that I expect when you come back in September or October. Oh, sorry, next August. We don't have to go too deeply into this, so I'm going to just put out there, the algebra or pre-calculus skills that you're expected to know pretty well. So let's just start. Oh, by the way, this video may turn out to be pretty long because I tend to make long videos. But obviously, at any time, since this is a video, at any time you can pause it, come back to it the following day or whatever if you feel like this is getting a little too long. You can also try to do this with like sort of the idea if you're going to do one skill at a time, even though I might go over like 3, 4, or 5 skills in this video. It is a good idea to do this video with a pen and paper as you kind of as I put the problem up on the screen. You could pause and maybe try to do it yourself ahead of me. But I am not going to collect that. That part is, I'm not going to collect it. So here we go. So here are the things that I feel like a lot of students who struggle in my calc class, in the AP calc class, when they come in with relatively weak pre-calculus skills, like algebra skills, this is where they struggle. So I'm going to go over number one. I think I'm going to start. Number one is factoring. And I'm going to go over 1 or 2 problems, probably one problem, factoring. And almost from here, and even though maybe you have never had this particular skill, but it really kind of lends itself to creating sign charts. Sign charts. So I'm going to go over it right now. Although in class, when we get to this in class in Calc next year, for sure I'm going to go over it. I don't expect everybody either to have watched this video, or even if you watch it, I'm still going to go over it because this is just such a important part of calculus class. So creating a sign chart. So let me see. Put the second one. What comes to mind? Definitely a big one is trig. Trig. Now, the trigonometry that is required for success in calculus is really not that deep. It is not like you must know ins and outs of all trig identities. There's almost no almost hardly any trig identities. Just the basic ones. But there is no reduction of power formula. There is no half angle or double angle. Although when you get to Calc 2, in other words BC, yeah, those skills actually are very, very useful. Okay, but right now I'm just going to go over trig a little bit of graphing, and mostly about trig values. Values. In other words, values of trig functions. So that's the second thing I'm going to go over. Number three, I want to go over is function operations, but more specifically, function composition. And I'm just going to do one example, probably, and most likely that you're going. Oh, actually, just something else came to mind. You know what? So I wasn't thinking of it. Now that I'm talking about this, I'm going to incorporate. So for inverse functions, or function inverse functions. Okay. And number five, and this is why the video might be pretty long. Number five, what was the fifth thing I was thinking of? Logarithms, right? Properties of logarithms. So logs, and I'll just put logs, kind of like this, logs. Okay, logarithms. Typically in calc we're dealing with ln, natural log, and that's how I usually pronounce it, ln, instead of saying the word natural log. I know some teachers kind of say out the whole thing. Okay, I'll just say ln, like this. Okay, so let's start with factoring. So I'm going to go over here, I'm going to do the next one. So one, factoring. Now, one of the, I want to say important, but of course it's important, but one of the fundamentals, skills in math in general, not just calc, but you have to be good at just the basic multiplication. Multiplication, so I'll put a multiplication, which leads to, of course, division. You must know this pretty well, because if you don't know how to, what factors make up 72 as an example. You're going to sit there and struggle, try to factor something, um, and it's going to slow you down. A lot of times your success will, I don't say depend, but certainly influenced by your basic skills. So let's start with this. Let's see. Let me come up with factoring a, and it's always, not usually, always polynomials. Polynomial that I'm going to be factoring. Um, let's say if I have f of x, so some function, like call it y. Yeah, that's just synonymous. So let's call, 5, I don't know, x to the, I don't want to get, I mean, most of the time you're going to be factoring quadratics, but at the same time, there is, kind of be a little higher. So we're going to go with 3 with power. So it's a cubic. But it's not just any cubic. We're just going to say, it's like, let's say minus what? So let's just, so that I'm kind of previewing so that it's going to be relatively easy to factor. So let's say 10x squared, and then followed by, okay, and hopefully this will work out nicely like this, okay. Notice how I don't have a fourth term here, because that fourth term would make things more complicated. I picked this kind of off the top of my head on purpose, where this is going to be pretty easy to factor. So as you're looking at this, you're treating this, whether this is a factoring a function or solving an equation. In other words, solve this for like this. Like this is going to be set. In calc, there's this process called, take a derivative, set it equal to 0, and solve. That's really where I'm going with it. You may not know or understand what I just said as far as taking a derivative, but that's fine. That's the calculus part. The pre-calculus or the algebra part is what kind of holds some students back. Anyway, so what you're doing is you're solving for this. Now, the first thing to notice is what? Well, there's a common factor. That's the first thing you should be scanning across. If there is no common factor, great. That step is done for you. But in this case, kind of look through this, and again, you could pause this and do ahead of me. But I'm just going to do it at this point. So I noticed the 5 is common between all of them, but also x is common between all of them. So my common factor is 5x. Now let's factor the other stuff. So this is going to be what? X squared. And I'm hoping that I pick numbers where they're going to be easy to factor or factorable. So this is negative 2x, and then followed by minus 8. Right, minus 8, and yeah, okay, minus 8. Now, you can always, of course, check yourself as by multiplying, by distributing this to make sure that you get the same thing, the original thing back. And I just did that. Yes, I did. Okay, so I didn't make a mistake here. Now, here comes the actual factoring. So 5x is just out here. This is going to be equal to 0. So this is, I'll use different color. This is x and x. Now, how do I make that negative 8? Well, negative 2 times 4 or 2 times 4. That's the way to think of it. One of them is a positive, one's a negative, because this is minus. However, the middle term being negative, that means the bigger number, the bigger will have a negative sign. So in this case, I think I could see that. This is a 4 and this is a 2. Okay, and just kind of let's verify it. That's a negative 8. This is negative 4 plus positive 2. Yeah, so this is my factored version of this. So there's the factoring part. That's kind of like the extent of factoring that's going to be required. Once in a while, you will have, with the leading term over here, will be a not simply 1, but like let's say 3. And other things going on. So yeah, it becomes a little more, whenever the leading term is not 1, it's always going to be a little more challenging, because now you have one of them is 3 and the other one is, and you're playing mentally, you're playing with numbers to kind of fit into this pattern. But I'm not gonna go over that whole lesson. If you struggle in general, if you struggle with factoring, spend whatever time is necessary, 1, 2, 3 lessons on it over the summer to become good at this. Okay, so let's continue. At this point, I'm actually going to go into creating a sign chart. right? So sine chart, and if you've never had it, great. I mean, well, you'll see. But if you've had it, oh, that's even better because it'll just solidify what you already know. Sign chart just basically tells us the behavior of the graph, like behavior, of the graph. Now I recognize what this looks like to begin with. I mean, this is a cubic with a positive. The first leading term is positive here, so I know this, and this is with complications here. So this would, like, if I had to visualize what this looks like, would be this, kind of like this. That's the end, yeah, and the ends would be like this. So this is a, from your pre-calc days, negative, oh sorry, positive, because there's an invisible plus, positive odd behavior. Why odd? Well, this term is odd, right? So this is positive odd behavior, so it's going to be whatever happens in the middle, I don't know, but this is positive odd behavior, kind of like this. And in our case, there's going to be like either a wave or waves inside here, because of the complications. Anyway, we are creating sign charts. So the first thing after we solve this, or get it to this point, we solve for the rest of it. So what's the x value? X, well, in order for this to be 0, this could be 0, right? Like if, this part is 0, the x is 0. From the first parenthesis, what's the value of x that would make the first parenthesis equal to 0? It must be 4. And of course, -2. So like this is, I don't want to call it pre-calculus. This is algebra, no more than algebra 2. Like you definitely, even in algebra 1, you encounter this skill. But yeah, we'll call it algebra 2 skill. Okay. Now, in order to create a sign chart, what I'm really doing is I am graphing the zeros. I'm creating a number line, and I'm going to put these zeros on there, meaning like here is -2, here is 0, and here is 4. Now notice how I'm doing, in a way I'm doing sloppy, but you really don't need to be very precise to like the scale. This is not a true scale, because if this is, this is 2 steps and this is 4, it doesn't look uniform scale. But that's fine. That really doesn't matter. What I'm looking for when I say sign chart, what I'm looking for is to create some kind of like pluses, minuses, or minus. I'm basically saying the behavior of the graph will be either above the x-axis or below the x-axis throughout the whole number line. So let me undo that. And how do I do it at this point? Well, if you know what the graph to begin with looks like this, right? And this is really not 100% of what I mean, this is 100% correct. It's just that this may not be the best way of doing this. But anyway, so if you know it's going to be in this shape, the only way that that's going to fit this shape is kind of like this, right? Like that's the shape. Because if you try to do something else, like maybe like this, but then a bounce over here and come up instead of going through, but then it's got to hit the 0. It's got to come back, it's come up and got to hit the 0. And here it's either going to come bounce or go through. Let's say, for instance, go through. Well, that's not a cubic. So I know this is wrong, right? This is for sure. This is a fourth power or some kind of even, negative. In fact, this is a negative even power, the appearance. And that would be an algebra 2 skill. Maybe pre-calc, but typically algebra 2 skill, the behavior of the graph and what happens with zeros. Anyway, so a safe way of creating a sign chart would be like at this point, plug in test values. When I say test values, something from this interval, something from this interval, and from this, and so on. We know we're going to hit these points. We know we're going to reside on the x-axis. This is really x-axis that I'm graphing. And I'm not doing the y-axis because that kind of visually complicates things. I don't want to graph this. I'm just going to create a sign chart. So I'm going to pick a number that's beyond, something to the smaller side, to the left side of -2. So any number will do. -5, -10, -1 million, doesn't matter. And I'm not looking for what is the y value there. All I'm looking for is its sign, plus or minus. So let's pretend we're going to plug in, so on this side, so let's put -10. Well, you plug negative 10 in the first, in this thing right here. So I'm going to highlight this in here. You put negative 10. And I don't care that it's going to be negative 50. All I care that it's going to be negative, right? So negative. Then I plug negative 10 in here, or some negative large number. And I know this is also going to be negative. So it's negative times negative. And all I'm doing is, well, let's figure out the last one. So put a negative 10 in here. Yeah, I'm going to be negative again. And because this is all multiplication, right, there is a multiplied, multiplied. My answer here will be, I don't care about the actual value. All I care about is a plus or minus, whether it's above or below the x-axis. And in this case, clearly, this will be negative. So that means anything to the left of this 0 will be negative. Negative, right? Like that's my, I'm in the midst of creating a sign chart. And sure enough, if I really wanted to graph it, which I don't, my graph would start off like this and go, well, we'll see in a second, whether does it go through or does it bounce, right? Okay, we'll do that. So over here, so the next one, so this is your first 0. So the next one at 0, we're going to plug in some number in between negative 2 and 0, which, just let's plug in negative 1. And again, I don't care about the result of it. All I care about is whether it's plus or minus. So putting a negative in here, this will be a negative, right? Negative 5 times negative, 5 times negative 1. Okay. Put a negative 1 in here will be negative. Putting a negative 1 in here in the second parenthesis will be a positive, because negative, 1 plus 2 is positive. So now when you multiply negative times it's a plus. It's a positive number. And so in between, in this interval, this is plus. So again, yeah, all I'm doing is I'm creating a sign chart which conveys the behavior of the graph in terms of, is it above the x-axis or below the x-axis? And certainly it kind of looks like this is what it's going to look like sort of like here's below the x-axis, here's above the x-axis, and I'm thinking that this is, the next one's going to be negative, and you'll see in a second whether it is or not. So what's going to be the next test point? Well, it's somewhere in between here and here, so let's plug positive 1, positive 2. Obviously, you want to plug some easy number. You don't want to, go, oh, how about pi? Let's put pi in here. Okay. So plug in positive 1. Well, this is positive, right? The first term is positive. Then plug in 1 in here. Well, this parenthesis negative. And plug in 1 in here will be a positive. And the answer is, positive times positive is negative. So sure enough, yeah, it's negative. In this interval, which represents this right here, the dip below the x-axis. How far the dip goes? Oh, I don't know. For all I know, it's like this, kind of like this. We don't know how far it goes. I just know it's negative, and that's all I care about. And lastly, plug in some kind of number beyond 4, like 5, 10, a million. That's going to be pretty clear. It's all going to be positive, because positive number in here is positive, or big number in here positive. Big positive number in here, 10 or 100. It's positive, and times another positive, right? So positive in here. So this is positive. So there's what I just did is create a sign chart. This is a sign chart. This right here. That. It shows me what my zeros are, and shows me the behavior of the graph. In other words, whether it's above the x-axis or below the x-axis in terms of plus or minus plus in this case. One of the things in the future, and I definitely don't want to go into it now, it's like, oh, what's the meaning of it? We're going to be focusing on where it changes signs. Like here we have a negative changes to positive, and sometimes it won't. Sometimes it'll be, in fact, I'll do a little bit of extension on this. What if I create a sign chart and I get this as my, let's say, negative 2, 1, and 5. It doesn't matter. It doesn't matter what they are. And let's say my sign chart is this: plus, 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 minus, minus, plus, plus. This is kind of randomized. The idea here is, well, if I were to create a graph that underlies this, it would on this side it would start with a positive. It would not go through because it did not change the signs. It would bounce, but it goes back up, but then it has to eventually come down to hit this spot. So it has to do this, and then it does what? Well, it goes through because now on this side of 1, it's a negative. So it's this. So it's got to go back up and then do what? Is it going to go through or is it going to bounce? Well, if it's changes signs, it's going to go from negative to positive. And does it ever come down again? No, it doesn't. It may wiggle. We don't know what happens, but it never comes down to a point where there's another zero anymore. So it'll always stay positive. So we typically indicate that with just kind of like this. You know, if we even need to do that, just visualize that. But the idea there is there's a sign chart. I know what the graph, or I know what the function behaves like. I may not know exact values of it, but that's not really the issue. That's not really the goal. I just say, well, let me just, it did not change signs. This is not a change of signs. This is a change of signs, and this is a change of signs. And in the future part of in the actual calc lessons, you'll come across either with me or in summary, your self-study for now. What's the meaning of this? When it changes from negative to positive, or from positive to negative, or it does not change signs at all. So like, what's the meaning of this sign chart? Okay, so to kind of recap or reemphasize, the goal there will be to create a sign chart. But in order to create a sign chart, you must be pretty good at just basic factoring, which of course you must be pretty good at just multiplication, and division tables. That can't slow you down. Over the years, where I've just kind of share, the people who struggle quite often in math, in calc specifically, are not the ones that are struggling with a brand new, oh my goodness, calc is really, really difficult. No, the ones that struggle are the ones with like gaps in their previous knowledge. So either you have to catch up very, very quickly, well, that's your choice, or a struggle, which of course I don't want you struggling. Okay, so that's number one, factoring. What was the next one? So what was the next one? Like, oh, trig. Yeah, let's go with trig. So let's go with trig from two quick perspectives. So to trig. We'll do a very, very quick graphing. Like, what does a trig function look like? Well, the basic, you have ui, well, just call f of x equals sine of x. And of course, this could be, with more transformations. Like this could be like 3 sine of 5x squared or something like that. Don't know. It doesn't really matter for the purposes of this little recap. The sine function looks like a what? Well, it's a wave. That's a kind of bad picture, and it goes like this. There's my sine. The highest it could be is +1. The lowest it can be is -1. It really doesn't matter what's inside. So, as an example, a sine of what's in the inside could be all really complicated things, like e to the 2x minus 4, right? Like something like that. It doesn't matter how big this gets. Sine, the most it could be is +1 or -1. Now this will have to I don't want to even think about graphing this. What would this, as x gets really large pretty quickly. Yeah, the frequency of this will be like up and down really, really quick. This is not going to be a uniform wave. This is going to be really, really compacted wave. But that's not the point. The point here is, I can visualize it. The highest it could be is 1, lowest it could be is -1. The only way to change that is if I put a number out front here. Then I could change its amplitude, or if I change the vertical shift by by shifting everything up or down, according to what's out here, but like -100. Well, I'm shifting everything down by 100. Okay. All right. So I don't want to go into transformations. I'm just going to stick with this, with just really, really basic stuff. So how about the second function? Let's say y equals, let's just call it g of x, the difference so that I don't have the same letter for. So let's say what's cosine of x? Well, cosine of x is the same thing as sine of x, but shifted by pi over 2, in other words, 90 degrees. So if I were to shift this, horizontally, I should say, not up and down, but side to side, there, I just created my cosine. That's a cosine. It looks, it's a wave. It's sinusoidal, as it's called, uh, but it's where it starts. But it has other, the properties that are very, very similar to sine. The highest it can be is positive one. The lowest it can be is negative one. Okay, for the y value. All right, so that's sine and cosine. I'll do one more, right? Like just in case you come across this, like what is y equals, let's call it h of x. What does the tangent function look like? Tan of x. Well, remember, tan is what? It's sine of x divided by cosine of x. That means what you're doing is you're kind of like you're taking the sine function divided by cosine function. So anytime you have a anytime you have a denominator equal to 0, and that's cosine equals to 0, you have a what? You're not allowed to divide by 0. You have vertical asymptotes. So if I were to graph this, which I'll do over here very roughly, so like right there, there's two vertical. So I'm just going to do this, kind of like I'm portraying these zeros. Go over here somewhere. I am going to have a what? I'm going to have a vertical asymptote. And tangent will reside, it will be a discontinuous function. It will reside kind of in here like this. So like this is what a tangent function looks like. And over and over and over. Now, very often we're not interested in forever. We're not interested. We're going to restrict our domain for some values of x. But this is just a very, a recap of, a year's worth, not quite a year's worth of trigonometry into like one little mini lesson. Okay, so there's your tangent function. You will, in calc, you will never be tasked or expected to graph it by freehand. In pre-calc, you should be able to. Yeah, not probably. I don't know about the AP whether they make you do that, but yeah, like that's expected. You should be able to graph this. Now, I am not going to go into other functions. There's reciprocal functions. Cotangent, secant, and cosecant. I'm not going to go into them, especially on the graphing part. Right? We don't do that in calc. We don't graph them. But you have to understand what they are, right? So in fact, let me kind of do this. So this is sine, cosine, tan, cotan, secant, and cosecant. So whatever they are, right? I'm not telling you like I'm being sloppy. I'm not writing the letter X here, but this relationship holds, and you kind of go inward. You pair them up. They are what to each other? They are reciprocals of each other, right? So tangent, as an example, is 1 divided by cotangent, and vice versa. Cotangent is 1 divided by tangent, right? And same thing as sine is 1 divided by cosecant, and cosecant is 1 divided by sine. So anyway, they're reciprocals of each other. So understand that. I'm not going to go into too deeply into identities. I think when we get to this in class, I will go over whatever the identities we really, really need. But you know what? The only identity I will. I mean, well, these are identities. So this is definitional identities. But the identities I'm talking about is, the most famous one is sine of x, or plus cosine of x equals to 1, right? Like everybody should know that. Now, fix it. Clearly I made a mistake on purpose. Fix it. So hopefully as I was writing this, everybody's like, whoa, what's he doing? No, that's not true. And this is not true. In order to be true, what has to be the case? These are squares. This is what's known as Pythagorean trig identity, because it really looks like a squared plus b squared equals c squared, because this is like this, that applies to a unit circle. So kind of like this. This is one. So I'm not going to go into the development of this, but this is a must. You must know this. But at the same time, right from here, you can develop all kinds of other things that you may need. As an example, uh, and I find myself kind of restraining myself from going into the full lesson on trig identities because I love them, and but I don't want to spend 3 hours doing this right now. But as an example, right from here, you could say, well, cosine squared equals 1 minus sine squared. Right, there's your, and sometimes this will be very helpful, to solve for something. You have a cosine squared, you want to turn into a sine. And I'm being a little sloppy here. I'm not writing x's, and you'll find that in class I tend to do that. Although if this is a real test, oh, I absolutely would not miss that. I'm being very sloppy now, but in a test situation, no, you need to pay attention. You actually put what's known as the argument there. It's sine squared of x. Anyway, right from here, you can develop other identities. I'm not going to right now. I'm just going to stop right here. And just, so the only, I do want to go over other trig things that you're 100% expected to know. That is trig values. So let's do this. So trig values. What does that mean? Well, trig function values, I should say. So if I were to say, question mark, what is cosine of, off the top of my head, let's say 14 pi over 3, like question mark. What is that? And you should be able to come up with that within, I don't know, like I don't know this angle off the top of my head, but I could do this in definitely less than 10 seconds. You should be able to come up with that. Whether you use the unit circle approach or alternative to that, depends on your comfort level. It depends on how your teacher taught it to you, right? So I tend to do it not unit circle approach, but then I tie it to the unit circle as I need to. Okay, so I'll put this up here. Maybe you could pause it and kind of do the problem yourself. I'll do this in a second, and while I'm at it, let me come up with something else. So let's say what if I want cosecant of I don't know, let's say negative what would that be? I don't know. Let's negative 17 over 17 pi over 6. I don't know. Question mark. And you could pause it, try to do this on your own, and we'll do that in a second. So in fact, I'm going to do one more over here. So that, let's say this is cotangent of what? Let's say cotangent of 29 pi over 4. Okay. Yeah, I already have an answer for that. I mean, I picked that number on purpose. It's really easy. Okay, but go ahead and pause it and see if you can do this. All right, let's hopefully you paused it. Now you're coming back and with either one or at least or 3 answers, but at least one. Let's do this one first. So let's go over here. 1. So the first thing is place the angle. Where is this angle? 14 pi over 3. I'm going to go pretty quickly. So 14 over 3, the way I tend to think of it, what's the mixed number here? 14 over 3. Well, that's 4 and 2/3, right? Like that this part. And I know there's a pi, of course, involved in it. Yeah, but I'm just telling you how I'm thinking of it. So this really is 4 pi rotation, and then plus 2 pi over 3. That's really what this means. Okay. Well, so what's a 4 pi rotation? Well, pi is 180. It's half a circle. So 4 pi is 1, 2, 3, 4. And then how much past that I have to go? I have to go this. Be comfortable as to what this is. 2 pi over 3 is over here. it is 120 degrees. So this angle, this right here, falls into which quadrant? Well, it's in the second quadrant. So I know my cosine there is what? Either positive or negative. So like I'm kind of doing this one step at a time. But what is, in this, well, and most of you probably learned it this way, maybe not, but all students take calculus. So in the second quadrant, sine is positive, but that means cosine is negative. And now the only thing that's left for me to do is come up with the actual value, like square, like the value. So remember what the values are, and I'm going to recap it down here. What the values are. Well, what's my reference angle right here? What is that? Well, that's pi over 3, because I went 2/3 pi. That what's left over is pi over 3. In other words, yeah, like 1/3 pi left. And now either on the side here, I'm going to write it to myself or just mentally think of it. Well, what's cosine of pi over 3? And hopefully this, within 2 seconds or so, this should come up, oh, that's 1/2. So in this case, the answer is a combination of these two things. The value is 1/2, and the sign on it, plus minus, it's a negative because this angle falls in the second quadrant, where cosine is negative in that quadrant. Had it fallen either in the first quadrant or the fourth quadrant, it would be a positive value. But in this case, it's a negative. Okay. All right. I think, that one's done, right? Now, if you're troubled, if you're struggling with where did this number, like how did you know this? Yeah, this is going to slow you down big time. Like when you get to calc, this cannot slow you down. Like knowing this. At the end, I'm going to recap it here at the end. Or maybe I should do that now before I actually jump to this. Let me do that. Let me tell you how I tend to, how I think of it, how I teach to my students, but I also do tie it together with because I know some other teachers teach it through a unit circle approach, but it really is the same thing. It's just the interpretation of it is a little different. So this is what I do when I do my trig values in my head. So let's create a table. Instead of creating a unit circle, I'm creating a table, which is the unit circle kind of in a circular way. So what are my special angles? Well, there is 0. I'm going to do it in degrees, but then immediately switch to radians because all of calc is done in radians. But these are 30, 45, 60, and 90 degrees. I typically, can I put 180 in here because that's a special angle? Yes, it is, but I really, there's nothing new about 180. It's already incorporated in here. Anyway, so these are my reference angles. So I'll just do the, theta reference. And this is in degrees, but what is it in radians? Well, this is 0, 0. So this is pi over 6, pi over 4, pi over 3, and pi over 2. So now I'm going to create the sine, table, but sine row, sine of theta, right? So for each, what's the value here? What's the value here? So I'm not gonna put squares on it. Give me 2 seconds. Okay. All right. So what is sine of 0? Well, through a unit circle approach or not. Actually, I'll do it a little bigger. So unit circle is kind of like this. What is the sine? Is the y value, the height. So what's the height right there? It's 0. So I'm just going to put this up here. So this is 1/2 square root of 2 divided by 2, square root of 3 divided by 2, and this is 1. You should know this by heart, be able to recreate this instantly. Now, how do I create cosine of this? Well, the cosine values are not reciprocal, but they are like a cross. They are crisscross of the sine values. In other words, you basically, I'm going to write this row, but in reverse. So I'm going to start with, instead of starting with 0, I'm going to start with 1. And then rewrite this in reverse. So this is this, this, this is square root of 2 divided by 2. This is 1/2, and this is 0. Notice how when I say crisscross, this is what I mean. This term goes here, this term goes here. This term goes here, this term goes here. The only one doesn't crisscross, because it does crisscross with itself, is the 45. Because for 45, from the trig, from a right angle trig, the adjacent side and the opposite side are the same. It really is the same value. Sine and cosine for 45 is the same. So I'm going to erase this for clarity. So like here's how I drill it into my students in pre-calc so that they know this by heart, and this you could create just by in reverse. Now, by the way, like where do these numbers come from? And that's a lesson in itself. Maybe you've had this in either SAT prep or geometry lesson back in geometry from right angle trig. It really comes from special triangles and using Pythagorean theorem to come up with this. But both in AP pre-calc or not even AP, just regular pre-calc, and for sure in calc, you don't have the time to develop this. You don't have the time to like, oh, let me come up with this number. You just know it. You just know it by heart what these numbers are. And the way to see these numbers on the unit circle is, well, they are these little pit stops along as you travel in a circular way. They are your x and y coordinates. This is the sign is the y coordinate. Unfortunately, it's very often students make mistake, including myself. I've done that many times, where because sine comes first, and you think that should be the x value. It's not. So as an example, here is a little triangle built into it. The x value is the coordinate for this point. Well, it is the cosine of that point. So this is like x comma y, but this table is just laid out in a circular way. Now, what's the benefit of using unit circle approach? Is kind of like, well, if it keeps going, if the angle, let's say, opens up 120 degrees, in other words, like to here, yeah, but that you still have right there, you have a 30, 60, well, that's a bad, doesn't look like a 120, it looks more than 130 or 140 even. Yeah, but so my picture's a little bit off. But the point is, there's a special triangle built into it. And you can tell from the unit circle is where the x's are positive or x's are negative just because you know the quadrants. Yeah, and as far as, how else you can do it, it's that all students take calculus. So if I land in the second quadrant, the sign values, all of this will be positive, the sign values. But if somebody's asking me the cosine values, oh yeah, my x value is negative because it takes me in a negative direction on the x-axis. But the y is positive. The y is a positive, which is the sign value, and so forth. I mean, you can make sense of this. We could spend a whole hour trying to unite or trying to connect the unit circle versus the chart that I just created. I tend to think of the chart as very quick. It just is put out this line. This line is just crisscross of it, and so much. To my mind, it's a little easier than doing the unit circle. Doing the whole unit circle on the test itself. Anyway, so I do want to demonstrate to do the tangent. So tangent, how does tangent appear on the unit circle? Well, it doesn't, right? But tangent is defined to be sine divided by cosine. Sine valued, so it really is this number divided by this number. So it's like a divide by, right above it. So what is 0 divided by 1? Well, it's instantly 0. What is 1/2 divided by this? Well, it's just 1 over square root of 3. The 2's cancel. Now, technically, if this is an FRQ and you're doing this on the AP test, you can leave it this way. This is a good answer. But we typically, if you say, well, let's rationalize this is going to be square root of 3 divided by 3. Okay, rationalize. Either way is acceptable to me. What is tangent of 45? 45 degrees, or pi over 4? Well, it's this number divided by itself. It's the same number. So it's instantly, and hopefully you recognize that instantly, tangent of 45, or anything that depends on 45, like 135, or what is the next one? 215, and so on, 350. So, no, 225, right? That was off. This is 1, right? Like this divided by this is 1. What is this divided by this? Well, it's square root of 3. And what is 1 divided by 0? Well, that's undefined. You're not allowed to divide by 0. And that's why actually on the previous one, the picture over here, tangent of right there, it's undefined because it's a vertical asymptote. It's doesn't touch it. Okay. Can't touch this. Okay. All right. So it's undefined. So there, like you should. I don't want to say memorize it because I never memorized the tangent except for I know it. Like I know this instantly. I know this instantly. I know this, and this way I always have to think about tangent of this. Oh yeah, it's this divided by this. So in my mind, I visualize this line because it's pretty easy. Oh, by the way, and what's another? I don't know if if your teacher kind of demonstrated this or not, but yeah, I'll just demonstrate it again. So if you have like sine, and the sign is 0, 1, 2, 3, 4. Just literally, right? 0, 1, 2, 3, 4. And then divided by 2, divided by 2, divided by 2, divided by 2, all of them. And then put a square root on each one, just the numerator. And then if you simplify, well, what is this? Well, that's just square root of 0 is 0. Divided by, there's no need to write that. That's just 0. All right, just like that. And what is square root of 1? Well, you don't need to write square root of 1. That's just 1. So this is 1/2. And that's exactly what we have here. That's 1/2. What's the next one? Well, this one doesn't simplify. Square root of 2 just stays a square root of 2. So square root of 2 divided by 2 stays. Same thing with square root of 3. It doesn't simplify. It stays. But square root of 4, well, that's just the 2 up top. Divided by 2 equals to 1. It's just kind of weird, almost coincidental thing. I don't know on the theoretical level what is the justification for it. And there may be, but I've never really heard a good explanation for it. But that's what it is. Anyway, I don't want to say, oh, in case you forget, because you really shouldn't forget. You should like once you learn this, if you need to write this literally 10, 20 times just over and over, so that it's completely ingrained in your brain, this part. In fact, you should know it. So like pretty much everybody should know this. Like 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 if you come up with a total stranger on the street and you say, what's sine of pi over 4? They should tell you on the spot. Oh, it's this. Like that should be instant. In fact, maybe here's my assignment for you in the summer. Go to your parents and ask them, well, what's cosine of pi over, I don't know, pi over 3? And they should instantly tell you, oh, wait a second, that's pi over 3. That's over there. This is 1/2. No, yeah, 1/2. Yeah, it's this. It's this right here. Pi over 3, 1/2. Yeah, I had to think about it only because I'm mentally switching them. I'm crisscrossing. Anyway, so let's actually do this problem, and because that's a lot of talk, and again, because you have the freedom, or you could pause it and just take a break if this is getting too long. All right, so I'm gonna erase this part and come up with this. Let's do that, or this one, whichever what the order. Let's do this, the second one, and this is third. Let's practice this. So cotangent of, I notice that this is going to be a what? This is something over pi over 4. I know the answer is going to be either +1 or -1. Why? Because cotangent and tangent, of a 45, and this is based on a 45 degree, will be 1, either plus or minus. I don't know. That depends on what? Well, it depends on which quadrant it lands in. But I know the answer is going to be either positive 1 or negative 1 because of pi over 4, this part, pi over 4. So let's see what pi over, so, well, had this been 28 pi, that would be like 7 pi, right? Like, 29 is divided by 4. That's in a mixed number format. It would be 7 and 1/4. So what's 7? 7 pi. 1, 2, 3, 4, 5, 6, 7. Oh, okay, landed here. So to go one more, we are in the third quadrant, right? And cotangent, both tangent and cotangent are what in third? Are in the third. They are positive. There's my answer. And that was, without the explaining part, without the explanation, it probably takes me 5 seconds to visualize this. Okay. Well, let's erase that. And let's do what feels like the most challenging one because of this. It's cosecant. It's not. I'm still going to do the same format. I'm still going to do place the angle of which quadrant we're in. Then I'm going to figure out whether it's positive or negative there and what's the actual value. So where is 17? Well, 6 goes into 17. Oh, not quite 3 times because it had this been 18. So what this is like if this was 18, that would be 3 full revolutions. But it's also notice it's negative, so I'm going to go negative revolution. 1, 2, 3. It would have been this had this been 18, but we have 17, so we're a little short. We're actually over here. Didn't make it all the way to this. And by how much am I short? Well, what is that? Well, that is pi over 6. Pi over 6. That's my reference angle. That's the one I'm going to be referring to in this grid. So what is, and so next question, well, what's cosecant? I don't know that off the top of my head the cosecant values. In fact, I don't want you to know them by heart. I want you to kind of recognize they're based on sine, right? This is based on sine. And normally sine of pi over 6 is 1/2. When I say normally, it's 1/2. It's from the table, or it's one of those you really must know. But since cosecant is a flip, it's a reciprocal of sine, this is 2 over 1, which is just 2. We don't need to write 2 over 1. And in this quadrant, in the third quadrant, sine is negative. There's my answer. So it's a combination of the. And did I have to use the unit circle approach? No, not really. But is it? Yeah, it's still there. It's the unit circle. I would have landed right here, and I would have to well, what's this angle right here? What's this? What's the coordinate right here? And I would say, right, well, the x is negative and the y is negative. So I know both, sine and cosine will be negative, and I just tend to do it the way I just showed you. That's my. I don't care how you do it. That's too small. I don't care how you do it, which what you learned it through unit circle approach, and you're comfortable. That's fine. Stick with it. But the point is, you can't let this skill slow you down. Um, okay, it's got to be 10 seconds, 10, 15 seconds. I can't see it going beyond 15 seconds for to solve that. Anyway, I think that was, let me see, I want to stop at, no more trig, factoring, already covered, function composition. Yeah, this is going to be pretty long, so I might want to actually pause and take a break. But same thing with you. I am going to make it into one video so that I can just post one video instead of doing multiple videos of this. But I may pause and just walk away, take a break, and come back. So let me actually do the function composition before the break, but then I'll do the other ones, function compositions. So function composition. Well, okay, so I'm composing a function. I'm doing operations with functions, but in a very peculiar way where I am. So let's actually define a couple of functions. Let's call it one of them by name. Just f of x is just a name. So let's call it, 3x squared plus 2x minus 5. I don't know, just that. And have another function, g of x, I don't know, call it cosine of 2x. Okay, so there's I could put parentheses inside, for the argument. This is called the argument. Or leave it without the parentheses. Okay. Um, okay, so what is it? If I were to add these two functions, it's literally I'm adding. If I'm subtracting them, and there would be nothing combinable in this case because they're not like anything like terms. Yeah, those are boring, really too simple of operations. Multiplication, in this case, if I multiply them, I'm basically doing a FOIL, like distribute. That's pretty boring. Division, yeah, I just write one on top of the other one to divide by and be done with it. Yeah, the one that's kind of, the more interesting one is what's known as composition, where I'm plugging one function to another. Now, what's the notation? In pre-calc, I think the notation is like, you might have seen that, or like G, O, F. This is not a multiplication, this little open circle. It's pronounced like an O, like of. This is F of G or F O G. You could pronounce it either way, F O G. But really what it means, inside the F function, you're plugging in G function wherever there's a letter X in here. So we'll kind of do both in this case, just kind of demonstrate. So if FOG would be, in a second I'll do that. And what is GOF? Well, inside the G function, I'm going to plug in the F function. And the order absolutely matters. The only, under what circumstances the order does not matter, in fact, that's one of the, tail sign, or telltale sign, is whatever that expression is if the order does not matter, if you get the same thing, that means these two functions would be inverses of each other, which obviously they're not. I mean, not in this case, they're not. But if they were, that means yes, they are the two functions are inverses of each other. Okay. So anyway, so what is FOG, or F composing, or G inside F? Well, wherever you see X in here, you plug in this whole thing. So this would be, for this case, this would be like 3 cosine squared of 2x. In fact, I don't even need this parenthesis, right? I don't need that. I'm going to redo it. So this is 3 in front of it, right? And then plus 2 times, well, x gets replaced by cosine of 2x. And if you wish to put, for extra emphasis, put a parenthesis in here. That's not essential. And then minus 5. And there's my composition. When we get to calc, when we get to what's known as chain rule, I'm going to emphasize it's actually this could be more involved with 3 functions. Technically, it could be like 4 or 5, whatever. It could be, not infinitely, but many functions along the way. We're in the intro lesson, we're only going to stick with 2 functions here, one function inside another. But it could theoretically be like G inside, going in this and then going H, kind of like this. It could be sorry. This is like, sorry, the notation was kind of bad. So like G of F of H of X, kind of like this. Yeah, that's 3 functions. 2 functions are inside, this function's inside here, and this is inside here, and so forth. Theoretically, this could be, absolutely doable. It's not even that difficult, frankly. But let me undo that. I don't want to go into that deeply into this lesson. When we get to calc, when we get to this lesson, I will definitely spend more time on complicated things. Anyway, let's do the GOF. We just did F OG, then the G inside F. So in this case, I'm going to plug this whole thing inside every time I see a letter X. Well, what's nice that there's only one place where there is a letter X. That's okay. So in this case, it's pretty easy actually. So this is going to be cosine of 2 times, and every time I see a letter X, in this case there's only one appearance of it, I'm going to plug in the whole f function. This is 3x squared plus 2x minus 5. And for emphasis, I could do this. Or I could, open the parentheses right here, this, and distribute this. So this is cosine of 6x squared plus 4x minus 10. And there is my function composition. Right, there's my, yeah, I have a one function inside another function. This function right here, and that's exactly how in calculus we're going to refer to it. Oh, this function, this is the inside function. This is inside, and this is outside function. And it could be like multiple, there could be a bunch of functions inside other functions. So I think I'll stop as far as function composition. Do I have the stamina? I do have the stamina, but I still want to do both of these, inverse function and log. I think I'm going to pause, but I'll come back in the same video. So you could pause it if you wish, or once I unpause it, you could continue watching this. So let me actually, where's the video pause, and